Welcome to the Armada EW podcast with your host Tom Withington at the controls. Concept of operations, or CONOPS, tend to be associated with a commander's intent on the battlefield. What are their goals, how will they be achieved, and what are their assumptions? Yet, the useful CONOPS philosophy has relevance beyond the battlefield, particularly at the research and development stage for military equipment, including electronic warfare systems. We're delighted to be joined today all the way from Maryland by Mack McKinney of smoothprojects.org. Mack is an experienced teacher and trainer specialising in CONOPS who has trained thousands of students around the world. Mack, welcome to the podcast.
Oh, thank you, Tom. Good to be here. Thank you very much.
So tell me about your overall approach to CONOPS at the system and software design, development and engineering stage.
I accidentally got into this whole thing. I didn't intend to have my own approach to CONOPS, but a few years ago, we were working on two non-traditional ELINT efforts, electronic intelligence. And we had, on one of them, we had 21 people scattered across 9 countries, and on the other one, a number of U.S. states involved. I wanted a CONOPS template and approach for a development project, not something that was a commander's concept or some military mission description, but something that would provide a framework or a nexus where all our developers and end users and our organization's established system engineering processes could kind of be all brought together on the projects. I needed a glue that would tie together all the pieces of our program over time and give us some design continuity. And I knew our contract wouldn't do that. Contracts, they're adversarial by nature. So we looked at all the CONOPS types and formats worldwide, and then we cherry picked from them. And we got the best of all of those, and we built the technical CONOPS, and it's on its, the 7th revision now, the latest being last month, December 2021, when we integrated it more fully with digital engineering and model-based system engineering. So it's a very different approach to CONOPS, and it's tailored, it's custom built for the development community to tie together what John Jumper used to call the 3 tribes: developers, typically contractors; government users, typically military; and then the buyers, the procurement community. And these tribes typically don't work well with each other, and they don't share their toys. So this is a way to tie all of that together to give the user, the warfighter, what they need.
With that in mind, how has the CONOPS approach assisted engineering and product development in the defense domain writ large, do you feel?
I can give you some examples of where I personally have used it and seen it used. I used it as a deputy chair of NATO Study Group 79. We were looking at non-traditional electronic intelligence, ELINT, and short uptime emitters. And that has supported several classified programs that are deployed now. Raytheon hired us to use this Tech CONOPS approach for their Joint STARS recapitalization program bid. And that would have been a $2 billion program had the Air Force proceeded with the procurement. I can talk about one pretty amazing system, the Air Force's Air Combat Command Gorgon Stare optical surveillance system. The U.S. government team used our Tech CONOPS template and tools. Lieutenant General David Deptula, U.S. Air Force, retired, said, "This CONOPS is bluntly clear on what the warfighter needs, and you people, government and developers, don't seem to have read it." He was upset that the user's needs were not going to be met with the system that was being designed and architected and built. So I think after that, the program review, everybody read it, and the resulting system more than met the user's expectations. Incidentally, technology marches on. That same optical sensor and processing technology has migrated to law enforcement and is rumored to be flying over Baltimore and other U.S. cities periodically to maintain surveillance track on people of interest, shall we say, weaving through streets and overpasses and tunnels. So we're proud to have contributed a little bit to the Gorgon Stairs users' needs and the whole thing being delivered to the warfighters. We have one major U.S. defense prime contractor where we teach several of these courses each year and have been since 2011. And they're applying our whole Tech CONOPS approach to developing and fielding all of their stuff, land, sea, and space systems. And we've taught this at the U.S. Navy Surface Warfare Centers, a couple of those, and to the Navy Cyber Command, but they don't tell us anything about how they're actually using it. They're rather close-lipped over there.
Matt, you've cited obviously a few EW examples there in our discussion so far. I wonder if you talk a little bit about how these CONOPS approaches are relevant specifically to the EW system and software design and development phase.
We didn't set out to design a development approach or framework like this that was ideal for radar and EW and SIGINT and weapon systems, but it turns out that is what we have stumbled upon. I wish I could take credit for coming up with all that, but that's really not the case. We just kind of wandered into this. But with modern EW and software design, we can't talk much about specific systems, but it's a user-driven project framework for agile developed systems, and I guess everything pretty much these days is agile, including ISR, EW radar, where users and real world events change the requirements almost weekly. So this is especially useful where the changing requirements and the ripple effect on downstream system utility and performance has to be constantly refactored back into the baseline design and approved by the users. We were teaching a class to the system architects at the Lockheed Martin Skunk Works, and I saw a presentation by Jeff Wilcox. I think at the time he was vice president of engineering. And basically he said system engineering getting most of the blame for the cost and schedule overruns. And we were seeing that especially in software intensive developmental systems like those in EW. And he said the old ways of doing system engineering must change because systems are moving past being just complicated to being complex. And the way he defined them, complicated systems have lots of parts, but we know how they interrelate and work together. Complex systems also have lots of parts, and we know sometimes how they interrelate, but it really cannot be completely decomposed, and the relationships are not always apparent, and unexpected events occur, I think was the way he said it. So that ties in with Michael Griffin, he used to the former administrator of NASA. He once blamed the system engineering community for being unable to predict how a design would meet objectives. He used the term pathetic, and he said something fundamental is missing from the whole system engineering process. I'm a little parochial, but I think what's been missing was a framework to tie all these pieces and people, the tools, the processes, and the people together, and the ever-present contractual documents that would work in parallel to the contract activities. And apparently, this is that framework.
Matt, finally, how might these approaches develop in the future, do you feel?
Well, the bad news is I don't think it's going to get any easier. Radars are becoming mind-bendingly complex, and artificial intelligence, or AI, is going to bring even more challenges for everybody. Multiple shooters are being coupled with multiple sensors, and at some point the reaction times that are required are going to be so short that human decision makers just cannot be in the loop any longer. So rules of engagement are going to have to be baked into the system. And I think worse yet, aside from ensuring EW system behavior, think about it, faced with AESA radars that can operate in multiple modes simultaneously with multiple simultaneous waveforms. I mean, developers need to be asking themselves, like Jeff Wilcox asked, what could this system or sensor do that we don't want it to do? I mean, how can we minimize unintended and completely unanticipated interactions between system elements? One saving grace is digital engineering and model-based system engineering. The DE can dramatically reduce the ambiguity and make what-if decisions and simulations faster and more workable. And portions of this whole tech CONOPS approach have become authoritative sources that are embedded in the reference architectures of these contractors' agile development activities. And I think that's going to accelerate as AI eases itself into our military systems. So the tech CONOPS approach ties together all the mission threads and the scenarios and the system features really well. The other thing I think we're going to see, Tom, is strong collaboration isn't just a goal for design teams anymore. I mean, COVID has made it a necessity. Virtual teams, we've had them part of major weapon systems for decades. For example, already at least 15 nations involved in building the F-35 fighter, with, I'm sure, several companies involved in each nation contributing, parts and subsystems and assemblies. So keeping all of that synchronized and coupled is a challenge. But as EW and radar and SIGINT systems become more and more complex, and now remember, we're past complicated, we're into complex, we're going to need even tighter collaboration between and among geographically dispersed engineering teams. And that's not just routine cooperation. This is real collaboration. They need to be able to finish each other's sentences. And our tech CONOPS tools are providing that deeply collaborative training and tools. Unfortunately, we don't have the luxury of time. The Chinese Communist Party is leaving us in the dust technologically. And through a combination of, I think, technology theft, collaboration with other pariah nations, and just old-fashioned internal R&D, the CCP is rapidly outpacing the U.S. We have got to wake up about this now.
Well, it's food for thought for all of our listeners, and something tells me, Matt, this is a subject we're going to be revisiting again, I think, in the very near future. So I'd just like to thank you very much for joining us. Any final thoughts before we go?
Yes, Tom, just one. Anybody can learn to use these 16 tools to collaborate better on programs and to drive risk down and to build more user-centric systems. We have our next public tech CONOPS class coming up 28 through 31 March. 2022, and anybody can attend that. It'll be a virtual class, 4 hours per day across those 4 days. I'll be leading that class myself. I don't allow the consultants to do this much as they would like to do this. I like this so much, I do it myself. Plus, I'll be available for an additional hour each day after class, and they can ask me anything session with the attendees. So there's no prerequisites, and the details are on our website at www.smoothprojects.org.
Matt, thanks once again for joining us. We really appreciate it.
Thanks, Tom. This was great. Thanks a lot for the opportunity.
And don't forget that there's more EW news and analysis at armadainternational.com/electronic-warfare. That's all for now. Thanks for listening.